Alrighty guys, so in today's lecture we're going to be talking about something called isotopes. Now before we get started, I just want to remind you of a couple things. The first thing is that while you're watching this video, I encourage you guys to take notes, okay? Nobody gets information just by looking at a video. Make sure you're taking notes, and not just taking notes, but you're also doing the problems with me. Okay, this will help you understand the material better, and you'll also have a little compilation of it when you take the quiz so that you can just go back to your notes. You'll find the problems, and that'll help you while you're taking the quizzes in this class. Okay, you're going to need two things for today's lecture. The first thing you're going to need is a periodic table, and the second thing that you'll need is a calculator. Okay, we're going to be doing a little bit of simple math, just adding and subtracting, and we're also going to be looking at the periodic table. So make sure that you guys have a copy of the periodic table with you, and make sure you guys also have a calculator, whether it's on your phone or you actually have a calculator out. Just make sure you have those two things with you. Alright, so before we get started on talking about isotopes, let's do a quick warm-up where we review the information from last time. So the last time we met, we talked about what an atom looks like, and we found out that atoms are made out of 3 subatomic particles. Okay, and this is the stuff that makes up the atom. Okay, so everything physical in the world, whether it's a solid, liquid, gas, plasma, whatever it is, they're all made of atoms. Okay, and atoms are made out of 3 different components. Those 3 different components, we're going to go over what they are in just a second. Okay, the first thing, I'll start from the bottom. The first subatomic particle is called a proton. Okay, and a proton has a positive or a plus charge. Okay, just like how when we have like a battery or a magnet, you guys know how they have a positive and a negative charge, right? So batteries, a really ugly battery, but batteries, or that's not even a battery, that's a magnet. So a magnet has a positive and negative charge, or when you have a battery, you know that one side is positive, one side is negative, just like how there's different electronic charges for magnets and batteries, so does the atom. The atom's subatomic particles have these electrical charges. So that's the first one, a proton. And the symbol for a proton is P+. Alright, the second subatomic particle is called a neutron. And a neutron kind of tells you what this charge is by its name. It's neutral. Okay, so neutral means that it has no charge. Okay, so a neutron has no charge, like a proton has a positive charge, a neutron has no charge. And then the last subatomic particle is called an electron, and the electron has a negative charge. Okay, so it would have the opposite charge of protons and electrons. So protons and electrons have opposite charges, positive and negative, and neutrons have no charges. And the symbol for a neutron is N0, and then electron is E-. Okay, so those are the 3 subatomic particles. Just make sure you guys keep that in mind before we move on. Okay, so the last time that we met, what we did was we went over how we can tell what an atom's identity is. Okay, and we said the last time that we met that the identity of an atom, so whatever element an atom is determined by the number of protons. Okay, so depending on how many protons an atom has, that tells us what element it is, what the identity is. Okay, so we're going to do a quick practice problem. So here it's asking us which element has 16 protons. Now in order to figure that out, what we need to do is we need to go to the periodic table. And so I'm going to go to the periodic table right here. And what we're going to do is we're going to look for the element or the box that has the number 16 above it. Okay, so if we look at the periodic table, you're going to notice that this element, this box, has the number 16 on top of it. Alright, so this number right here, what it does is it tells us the number of protons. How many protons that element has. Another name for it is the atomic number. Okay, so we're looking for the element that has 16 protons, and so we look for atomic number 16, the number on top where it's 16, and we're going to notice that the name of the element is sulfur. Okay, so the name of the element is sulfur, and if you don't want to write sulfur out, you can just write the symbol, which is S. Okay, so sulfur has 16 protons. Okay, so here we went from protons to element. In this next question, we're going to go the other way. Instead of telling you how many protons there are, I'm asking you how many protons does copper have? So we're going to have to look for copper on the periodic table. So you guys can skim through the periodic table and you'll find that copper is right here. Copper is, the symbol for copper is Cu. And how many protons does Cu have? Well, we said it's the number on top, the atomic number. And it looks like it has 29 as the atomic number. And we said the number on top is the number of protons. So copper has 29 protons. Alrighty. So that's how we figure out what element an atom is depending on the number of protons. Now, before we move on, I kind of want to introduce the idea of isotopes to you guys. Okay, so another way you can think about isotopes is they're different forms of the same element. Okay, so what does that mean? Okay, so an isotope is a different form of the same element. So let's kind of think of it in terms of something that we're familiar with. Okay, so I really like soda, and so you know how there's different types of soda, right? There's like Coke, there's Sprite, there's Dr. Pepper, and the list goes on and on. Okay, so let's just stick with these for now. Okay, so you guys can kind of think of elements as these different soda brands. Okay, so one element could be Coke, which is still soda, but it's different from Sprite, which is also different from Dr. Pepper, right? So these different types of soda, you can kind of think of them as elements. Okay, but we know that for sodas that there's different types of the same soda. So for example, my favorite is Coca-Cola. And then there's Diet Coke. We also know that there's a Coke Zero. There's Mexican Coke, the best one that comes in the glass bottles made with real sugar. There's Cherry Coke, right? There's all these different types of Coke, and the same thing for Sprite. We know that there's Diet Sprite. I think there's a Sprite Zero, right? I don't know what the other different Sprites are. I'm a guess there's a Cherry Sprite and a Mexican Sprite, but let's just kind of leave it at that. We also know for Dr. Pepper, there's Diet Dr. Pepper, right? And so let's just kind of not go through all of these, but you kind of get the point, right? Different sodas have different types of the same soda, right? And these different types of the soda, you can almost think of them as isotopes. Okay, so these different types of sodas can be seen as isotopes if we look at these brands of sodas as elements. Okay, so instead of looking at Sprite, so let's forget about Sprite and Dr. Pepper. Okay, so we're going to erase that. Let's think of this as, let's look at elements now. Okay, so if we look on the periodic table, one thing that you guys are probably familiar with is the element oxygen, right? So oxygen is on the periodic table. Okay, the symbol is O. And oxygen, there's actually different types of oxygen, and these different types of oxygens are called isotopes. Okay, so there's a bunch, but let's just keep it simple. There's oxygen 16, there's oxygen 17, oxygen 15, etc., etc. Okay, and so all these different types of oxygen are isotopes. They're all oxygen, but they have different types of oxygen. Okay, so the key thing to remember is that all of them, since they're still oxygen, they have the same number of protons. Okay, now what makes them different though? What makes them different is the number of neutrons. Okay, so make sure that you guys write this down. These are probably the two most important things for today. Okay, different isotopes have the same number of protons, but the number of neutrons are different. Okay, and again, just like how Coke has different types of Coke, they're all still Coke, but they're all a little bit different. The same thing with elements. Every element on the periodic table has different isotopes. Okay, and the difference is caused by the number of neutrons. They still have the same number of protons. Okay, but unlike Coke or sodas, where the differences, they kind of make a difference, but not really. They're still all soda, and you just drink them, and they're still pretty good, even no matter what type of soda it is. Isotopes can change how an element functions. Okay, so we're going to take a look at a very famous example. So I don't know if you guys know about uranium. Okay, you guys might have heard about uranium, but uranium has two different types of isotopes. Okay, so if you look at uranium on the periodic table, you guys can pull that up right now. It's going to be on the very bottom. So once you get to the periodic table, go to the bottom and kind of go towards the left side. Okay, you're going to find uranium. All right, so uranium is number 92 on the periodic table, so that means that uranium has 92 protons. Okay, so here we're looking at two different types of uranium. So uranium-238 and uranium-235. Now, uranium-238 is pretty simple. You actually probably can find them in rocks around you. Not a lot, very little, but the uranium, you can just find these in rocks. Okay, and they're very stable. What stable means is it really doesn't do anything. It just kind of sits there. Okay, but uranium-235, even though it's still uranium, is used for nuclear fuel. Okay, you can't really find this in nature. Most of it is manufactured. So people have to take uranium and they need to turn it into uranium-235. Now, if you notice, the functions are very different. Uranium-238 is very stable. It doesn't really do much. But uranium-235, what is it used for? It's used for nuclear fuel. Okay, so you can tell just by looking at these two examples that even though they're the same element, they're both uranium, they both do very, very different things. But since they're both uranium, they both still have 92 protons. Okay, so uranium-238 has 92 protons, and uranium-235 also has 92 protons. Okay, so what is different about them? What's different about both of them is they have a different number of neutrons. Okay, that's what's different. They have the same protons, but they have different neutrons. Okay, so how do we figure out how many neutrons they have? It's actually very, very simple. All we need to do is we need to look at something called the mass number. Okay, make sure you guys write down this formula because we will be referring back to, or we'll be using this for our assignment and for the rest of this lecture. Okay, so the mass number is the number that's in the back of an isotope. This number right here and this number right here, whatever's in the back of the isotope is called the mass number. Okay, this is the mass number. Okay, and how do we get the mass number? All we need to do is we need to add the protons and we need to add the neutrons. Okay, super simple. So let's try that out with both of these examples right here. Okay, so all we need to do is plug and chug into this formula. So the formula says mass number. So the mass number is the number in the back. So let's start with this problem first. Uranium-238. The mass number is 238. It's the number in the back. So we can just put 238 right here. Equals, okay, the number of protons. So Since it's uranium, we know how many protons it has. We just need to look at the number on the top of the box. It has 92 protons. So since this is the number of protons, we can just plug in this number right here, 92. And it says plus number of neutrons. So I'm just going to put the number x because this way it'll look more like a math problem. Okay, so we have our problem right here. It has 238 equals 92 plus x. We're looking for x. We're looking for the number of neutrons. How do we do that? How can we isolate x? Pretty simple, right? We just need to subtract 92 on both sides. If we subtract 92, these can cancel out. And all we need to do is solve this out right here. 238 minus 2 will give us our minus 92 will give us our answer. So I'm just going to get my calculator. And I'm going to do 238 minus 92. And then my answer is 146. So we basically just found out how many neutrons we have. So uranium-238, basically what we figured out was that it has 92 protons and it has 148 neutrons. Okay? And if we want to double check our work, all we need to do is add these two numbers together, 92 and 140. Oh, why did I write 148? Sorry about that, guys. Should be 146. See, and you could see, and this is a nice segue into what I was going to say next. You can check your answers by just adding the protons and the neutrons. So 92 plus 146, and it should give you the number in the back, 238. Okay? Alright, so I'm going to give you guys a second. You can pause the video and try out the second problem. Try to find out how many neutrons uranium-235 has. Okay, so if you guys need a little bit of time, you guys can just pause the video. Try to find out how many neutrons uranium-235 has. Alright, so hopefully you're able to figure that out. Let's just plug and chug into the formula. Super simple. Since it's uranium-235, we can just put in 235 right here equals how many protons? Since it's still uranium, it still has 92 protons. Plus, and I'm going to put x for the number of neutrons. So in order to find x, all we need to do is minus 92. Minus 92. These can cancel out. And then for my final answer, you get 235 minus 92. And your answer is 143. Okay, so what that means is that uranium-235, it has 92 protons and it has 143 neutrons. Okay, you could have also done that by figuring out, hey, 238 minus 235 is 3, and then you had to just minus 3 right here. So that way works, but either way, as long as you got 143 neutrons, you're good to go. So you notice there's not a big difference between 238 and 235. They both have 92 protons, except this one has 146 neutrons, this one has 143. And that difference changes how they work. 3 neutrons is the difference between having a stable atom that you can find in rocks to one that's used for nuclear fuel. And it's very unstable. If you're near it, it'll give you cancer. Not very good for you. Not fun stuff. Okay. So those are isotopes, 2 different forms of the same atom. Alright, so with that being said, we're just going to go into a bunch of practice problems. We're going to spend the rest of the lecture doing practice problems, and a lot of these problems are the same ones that are going to be on your assignment for today and your quiz, so just make sure that you guys are following along and trying the problems out, okay? Alright, so let's start with problem number 1. We have magnesium 26. So magnesium 26, first thing it asks us to find is the number of protons. That should be pretty simple. All we have to do is go to our periodic table and look for magnesium. So you guys can look for magnesium. You will find magnesium in the top left. Okay, so to figure out how many protons it has, we just need to look for the number on the top. The number on top is the number of protons, so it's the number 12. So I'm just going to draw an arrow so it's easy to look at. There you go. It has 12 protons. Now, to find out how many neutrons it has, all we need to do is use this formula right here. The mass number is the number in the back. So 26, copy the equal sign, equals the number of protons. Magnesium has 12 protons, plus the number of neutrons. I'll just put X. And so how do we find X? All we need to do is subtract 12 from both sides. Okay, a lot of you won't even need a calculator for this. You'll know that it's 14. So that means that X is equal to 14, which means that there's 14 neutrons. All right, so the next thing we're going to go over is how to write the isotope symbol. So for the symbol, all we need to do is we need to look for the symbol for magnesium. We see that the symbol for magnesium is Mg, so I'm just going to write Mg. Okay, and what I'm going to do now is in the top left-hand corner, I'm going to write the mass number. The mass number is right here. It's how many protons and neutrons there are. There's 26, so I'm just going to write 26 on the top left-hand corner, and this is going to be your symbol. So all you need to do is put the mass number on the top left, and you just need to put the symbol, and that's it. Okay, so the isotope symbol for magnesium-26 is 26 on the top left, Mg. Alright, so if you guys think you could try this next problem on your own, pause the video and try it out, but for everybody else, I'm going to take it step by step. So we have 19 Ne, so we just said that this number on the top left is the mass number. Okay, and we know that the mass number is equal to the number of protons plus the number of neutrons. Okay, which is helpful because we're looking for protons and neutrons. So since we're looking for Ne, we're going to be looking for that on the periodic table. So take a second and look for Ne on the periodic table. Okay. So if you guys can find it, Ne is going to be on the very far right of the periodic table. Okay, the very far right. And you're going to notice that Ne has the number 10 on top of it. So we know that if it's the number 10 on top, that's going to mean it has 10 protons. All right, the number of neutrons. Okay, to find that, we need to use this formula right here. So we can plug in two of them so we can find neutrons. So the mass number is 19, so I'm just going to plug in 19 equals, how many protons are there? There's 10 plus neutrons. So to make neutrons by itself, we just need to subtract 10 from both sides. This is going to cancel out, and you'll get 9. So that means how many neutrons are there? There are 9 neutrons. Okay, so we have the symbol, so now we can write the name. The name is right here, this form right here. All we need to do is write the name of Ne. The name of Ne is neon, and then we can just write the dash, and then we can write the mass number, 19. Okay, so we write the name first, we write a dash, and then we write the mass number. Okay, and that is how you write the isotope name and the isotope symbol. All right, let's move on to a couple more problems that you'll see on your assignment. Okay, so here it's asking you to find the symbol and the name of the atom with 82 protons and 126 neutrons. Okay, so the numbers are a little bit bigger, but it's still basically the same thing. Okay, so if you notice, it has 82 protons. So all we need to do is go on the periodic table and look for the number 82 on the top of the box. All right, looks like we found it. We just need to go down a little bit and to the middle. So the element that has 82 protons is lead. Okay, so we're gonna write the name lead. Okay, and I'll write the symbol too. The symbol is Pb. Okay, like Pb and J, but don't write the J. Lead is Pb. All right. Next, we need to find if we're gonna look for the symbol and the name, we're gonna need the mass number. Okay, and how do we find the mass number? The formula is protons plus neutrons. So this time we don't have the mass number. Instead, we have protons and we have neutrons. So I'm looking for mass number. So to find the mass number, I need to add protons plus neutrons. So that's very easy. All we need to do is pull out a calculator, unless you guys can do this in your head, and do 82 plus 126, and that'll give you 208. Okay, so to write the name, so I'll put the name right here. In order to write the name of the isotope, we just put lead-208, and then in order to write the symbol, we just write the symbol Pb, and then we just put the mass number 208 on the top left, and this will be your final answer. All right, super duper easy. Okay, let's keep doing a couple more practice problems. All right, so here in this problem, it's asking you to draw a picture of lithium-5. So before we start anything, we're going to look for lithium on the periodic table. Lithium is going to be on the top left-hand corner. Okay, so it says to label the protons, neutrons, and electrons. So in order to solve this problem, I need to know how many protons there are, how many neutrons there are, and also how many electrons there are. So protons is probably the easiest. We just look for the number on the top of the box, 3. So we know that lithium has 3 protons. Okay, let's think about how many neutrons it has. We have lithium-5, so we have the mass number 5. We know that the mass number is equal to protons plus neutrons. So if we have 3 protons, if there's 3 plus what is 5? Pretty simple, right? It's 2. So it has 2 neutrons. And then lastly, the electrons, since this is a neutral atom, there's no charge. It's going to have the same number of protons as electrons. Okay? So there we go. We got 3 protons, 2 neutrons, 3 electrons. So let's draw our atom. We know the protons are in the middle, so I'm going to draw 3 protons in the middle. Think about the neutrons. There's 2 neutrons, so I'm going to draw 2 neutrons in the middle. And then there's 3 electrons, so I just need to draw 3 electrons around the nucleus. And there we go. That is lithium-5. Okay, guys. I know that this has been a lot of problems, but we'll do one final problem just to make sure you guys are ready for your assignment, because your assignment is going to look exactly like the next problem. Okay, so let's go over that and then we'll be all done. Okay, so in your problem today, you're going to have something that looks like this. In your problem, you don't need to copy down the table. All you need to do is just write the answers in the same order that we give them. Okay, so here it says it gives us the isotope name. And all we need to do is we need to fill in the number of protons, neutrons, and electrons. Okay, so it looks like we're looking at the element potassium. Okay, we're looking at potassium-38, and we're looking for potassium-40. Okay, so the number of protons is very easy for both of them. When we look for potassium on the periodic table, we'll see that it's number 19. So how many protons does potassium-38 have? It's potassium, so it's 19. How many does potassium-40 have? Well, it's also potassium, so it's 19. All right, there we go. We're a third done. We can actually fill out the electrons too. If we look at potassium-38, we'll notice there's no like positive or negative sign next to it, so we know that this is neutral. Okay, if it's neutral, that means there's the same number of protons and electrons. And if we look here, this one is also neutral, so that means it has the same number of protons and neutrons. Okay, so we're basically done. We just need to find the neutrons. Okay, we learned earlier today about isotopes. We know that the mass number is equal to the protons plus the neutrons. So we just need to do this problem for potassium-38 and potassium-40. So let's do 38 first. So 38 is the mass number, so that means that we have 38 equals, there's 19 protons, so we just plug in 19, and then plus the neutrons. So how can we get this one by itself? We just need to subtract by 19 on both sides. They're gonna cancel out, and you could punch it into your calculator, but you should also get 19. So that means there are 19 neutrons in potassium 38. Okay, so if you ever want to check your work, just remember the number of protons and the number of neutrons, it needs to equal the mass number. So 19 plus 19 is 38. That's how you know you did it correctly. All right, so let's try it for the next one. Let's do it for potassium 40. Okay, so same thing. We just need to plug in the numbers. Okay, so potassium 40, it has a mass number of, you guessed it, 40. So we plug in 40. How many protons? It has 19 protons. Plus how many neutrons? We don't know, so neutrons. So how do we get neutrons by itself? You just do minus 19 on both sides. These can cancel out, and then you'll get 21 neutrons. Okay? And again, to check your work, just add them together, and you should get 40. And there you go. That's basically what your assignment is going to look like today. Pretty simple. You just have these boxes, and you just need to fill them out. Oh, just for fun, let's write the symbols too. Okay, because I know you guys are probably loving this right now. Okay, so let's write the symbols. Okay, so the symbol for potassium 38, all we need to do is get the symbol for potassium. The symbol is K. So I'm going to write K. And then on the top left, I just put the mass number. The mass number is 38. So I'm going to put 38 on the top left. And then for potassium 40, we just write the symbol K because it's still potassium, and we just put the number 40 on the top left. Alrighty guys, so hopefully that helped. Make sure you guys get started on your assignment. I recommend that you do it on a piece of paper instead of a Google Doc this time. I'm on Zoom right now if you guys need any help. So please let me know if you need any help. But best of luck with today's assignment. See you next time.